Hey everybody, let's talk about section 3.2 B, talking about sine, cosine, and tangent. So just like when we pronounce the following names, Mr. Jones and Mrs. Smith, remember these are abbreviations. Just like when we look at this, this says sine of theta, cosine of theta, and this is tangent of theta. Those three-letter abbreviations are not pronounced sin, cos, and tan. They're sine, cosine, and tangent. Okay? Remember that we have so, ka, toa, where this S stands for sine, this C stands for cosine, and this T stands for tangent. Okay? So whenever we go from the perspective of a given angle, so sine of theta means that we mark from theta. This is our angle, and the side directly opposite to it is the opposite side. The hypotenuse always stays the same. It's always opposite the 90 degrees, and the adjacent is always next to the theta. So with that said, we know sine is opposite over hypotenuse. Cosine is going to be the adjacent over the hypotenuse, and tangent is the opposite over adjacent. Okay, just like when you learned SOHCAHTOA. So let's talk about what that looks like using SOHCAHTOA in the unit circle or on a circle. So remember that if this point here is x comma y, we can draw this down. It creates a right triangle. That this distance from the origin to this point is that x value, or that horizontal displacement from the origin. And that this vertical line is the y value from the horizontal x-axis, okay? So remember here, as we're talking about sine, that it's the vertical displacement over the distance between the origin and the point, okay? So we say vertical displacement over the origin of the point. Otherwise, we can call this the y value. We see this right here. Come on. So we see this as the y value, the opposite side over the hypotenuse side. And remember, we call that hypotenuse side, that is the radius, okay? So we know sine is going to be y over r. Cosine is the horizontal displacement from, so that's horizontal here, over the distance between the origin and point P. So that's here. So that's x over r. Whoops. X over r. And the tangent is the vertical displacement from P to the x-axis. So the vertical displacement is this here on the y. And the horizontal displacement from the y-axis, so that's our x value. So that's going to be y over x. Okay, actually, sorry. This is supposed to go here, y over x. And that's because I want to show you one more thing about it. That when we're talking about y over x, so let's kind of talk about, just really quick, something random and separate. So if I talk about sine, and if I divide it by the cosine value. So I know sine is y over r, and cosine is x over r. So if I divide two fractions, I know I can multiply them by the reciprocal. So this would be r over x. I can cancel out those r's, and I end up getting y over x. Well, I know that if tangent is also y over x, that's like saying sine over cosine. So there's two ways to look at tangent. You can say that it's y over x, or you can say it's sine theta over cosine theta. Okay, looking at the next one, let's go ahead and apply some of this knowledge. So again, if we're looking for sine, remember that's opposite over hypotenuse. We also can say that this is the y over the radius. So if I'm looking here at this point, remember this is x comma y. and this is -3, 1, where this here is your radius. Well, we know we have to find the radius. You can use Pythagorean theorem to find the radius, where we know a squared plus b squared equals c squared. So these two sides are -3 and 1. So we're going to find that hypotenuse. So that's going to be 9 plus 1 is c squared. That's 10. Let's take the square root of both sides. So we get c equals the root of 10. It's not cute, but it's what it is. So we're going to say it's the root of 10. Let's use it. So if I know y over r is going to be 1 over the root of 10, keep in mind that you need to rationalize anytime we have a root in the denominator. So I'm just going to multiply by that root. We multiply it across. Root 10 times itself is just 10. And 1 times root 10 is just root 10. So that's our value for sine. Let's talk about cosine. Remember that cosine is adjacent over hypotenuse, which is x over the radius. We know the x value is here at -3 over the radius is the root of 10. Again, we're going to rationalize it. And we get -3 root 10 all over 10. And then finally, we're going to find tangent, which is opposite over adjacent, or y over x. Remember that our x value was here at -3 and our y value is here at 1. Therefore, it's just -3. Oh, I missed it. Sorry, I mixed it up. Let me go back real quick. I switched it. The y is the 1. Whoopsie. And the x was -3. My apologies. I mixed them up. All right, let's look at this next one, sine. So again, we're looking at this angle. It hits right here. And to go from 3 all around, why did they tell me that this is 6, 0? Well, that's because this radius is 6. So if that radius is 6, so is this one. And I know that if this is the point 2.6, -5.4, if I draw this straight up, this distance here, this x distance is going to be 2.6. And this y distance here is going to be -5.4. So we've got r, x, and y. So we know sine is opposite over hypotenuse, or y over r. In that case, it's -5.4 over 6. If I put that in my calc, I get approximately -0.9. For cosine, I know what's adjacent over hypotenuse. I know that's x over r. So the values are x, which is 2.6, over the radius is 6. Plug that in your calculator. You get approximately 4.33. And finally, tangent is adjacent. Opposite over adjacent, which is y over x. Y is -5.4 over x is 2.6. And we get approximately -2.077. So let's talk about when the radius is no longer a different value, but when it's the unit circle. Remember, the unit circle was when the radius is 1. So if sine is up here, y over r, then y over the radius of 1 would just be y. So that's for the unit circle. And the cosine value of x over r when the radius is 1 is just x. Tangent is still going to be the y over x. But this is the shortcut for when the unit circle is there. We can just trust, therefore, that if I'm looking at the point x comma y, that's also like looking at the value of the cosine of theta comma the sine of theta. Okay, so that whatever the x value is will give you your cosine. Whatever the y value is will give you your sine. All right, let's find these last 3, and then we'll be done. The figure below, it gives you the center, the origin, and the angle. So let's find angle, sine theta of angle A, or sine of angle A. So here's our sine. If I bring this up and over, remember that this is our x comma y, and this here confirms that our unit or our radius is 1. Therefore, this is a unit circle. Since this is a unit circle, I know the sine of A is just y. Therefore, y is negative 0.76. The cosine of it is just the value of x, which is here, negative 0.65. And tangent is going to be y over x, which is negative 0.76 all over negative 0.65. Put that in your calc, and you get approximately positive 1.169. All right, that's all for today.